Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZAHUDIN. My metric number DN180066. My supervisor, who is TS Dr. Nurhanis Hayati binti Hairum, and my co-supervisor TS Zarizi bin Awang. And in this video, I will like to present about my final year project 1 with title The Effect of pH and ZnO Loading on POMSE Treatment via Membrane Photocatalytic Reactor. Introduction. Background research of this study. Palm oil mill is one of the main sectors that contribute towards the economic growth in Malaysia. Regrettably, it was also contributing to the pollution of the environment due to the production of waste, which is known as palm oil mill effluent. POME consists of highly concentration of organic matter, chemical oxygen demand, and biological oxygen demand, which can pollute the environment severely. POME was treated through biological treatment and produced palm oil mill secondary effluent, which is also restricted from being released into the stream. The conventional treatment for POMSE is ineffective as the result does not satisfy the discharge limit by the Department of Environment and Environmental Quality Act due to the high BOD and COD level. The impact of POMSE, it can pollute the environment, harm the aquatic ecology, and affect the human health. Thus, the study is proposed to improve the POMSE treatment through the use of MPR and ZnO clay as photocatalysts. Okay, for the problem statement of this study, the first one, POMSE treatment via conventional method do not comply with the standard from the DOE Malaysia and EQA 1974 as shown in the figure below. This is referred to the second problem statement of this study, which is POMSE behaviors including bad odor, brownish in color, high BOD and COD and turbidity, which will affect the aquatic ecology if discharged without proper treatment. The third one, which is the challenges in separation and recovering process of nanoparticle as photocatalyst in wastewater treatment. Research objectives. There is 3 objectives of this study. The first one, which is to synthesize ZnO clay via precipitation method. The second one, to evaluate the effect of pH and ZnO clay loading on palm oil mill secondary effluent treatment via membrane photocatalytic reactor. And the third objective, to elucidate the mechanisms of membrane falling according to the theory of blocking filtration laws. Ladies and gentlemen, we continue with the scope of research. The first one, synthesis of ZnO clay via precipitation method. The second one, evaluation of the effect of pH, which is in acidic, neutral and base condition, and ZnO clay loading in MPR for POMSE treatment. The third one, analysis of the permeate quality in terms of pH, color, BOD, COD and turbidity. And the last one, elucidation of membrane falling mechanisms using model fitting in MATLAB software according to the theory of blocking filtration laws. Literature review. Palm oil mill secondary effluent. POMSE is the result of pre-treatment of POME, which is collected from the polishing pond. POMSE had undergone several conventional treatments such as pond system, open tank digesters and extended aeration system. Unfortunately, the organic pollutants in POMSE cannot be treated as it has complex molecular configuration, poor in biodegradability and has high toxicity. As a result, the treated POMSE has better BOD, COD and turbidity level than POME, but still not comply with the discharge limit. The brownish color is due to the decomposition of lignocellulosic compounds such as fatty acids, humic acid and crushed palm nuts, which are harmful to the aquatic life. The high in turbidity may inhibit the penetration of light source into the water and cause shortage of photosynthetic organism activity. Okay, ZnO nanoparticles. ZnO nanoparticle is an inorganic compound which also known as semiconductor that appears as white powder. It has extensively studied as photocatalyst for wastewater treatment due to its favorable optoelectronic and catalytic properties. It has a good potential as a photocatalyst as it has high photosensitivity, chemical stability, high reactivity and surface area and low cost. However, the ZnO is tend to agglomerate during the preparation and application process. Clay properties. Clay is a naturally occurring geometrical which are the major solid of cohesive soil. It is a greyish or white powder with a soft texture. Other names of clay, which is kaolinite, elite, morillonite and chlorite. Clay with high amount of kaolinite is known as a kaolin and this type of clay is used for this study. Next, the clay structure. As shown in the figure, it is a lamellar structure of clay which in combination of oxygen, hydroxyl, aluminium and silicon. Okay, synthesis of ZnO clay. Precipitation method is a simple and cost-effective method used to produce nanoparticles. It gives high purity, homogeneity, short preparation time, and low reaction temperature. Clay is used as a support for the ZnO as it is denser, has large number of absorption and reaction activation sites, stable structure, and has a unique spatial structure for varied dimensional assembly. Anchoring or immobilizing photocatalysts on clay surface helps to increase the active surface size, lower the agglomeration, and enable the recovery process. Suitable pH and amount of photocatalyst loading will provide the process with optimum condition to carry out the photocatalytic degradation activity. Okay, we continue with the membrane photocatalytic reactor. MPR is known as hybrid system due to the combination of photocatalytic degradation process and membrane filtration system. MPR enhance the capabilities of both standard photoreactor and membrane processes, resulting in the synergy of both technologies to reduce economic and environmental implications. It allows higher surface area of contact between photocatalysts and the pollutants which benefit for the photodegradation process. Membrane used for the MPR is nanofiltration. It is used as it offers several benefits such as able to remove low molecular weight and soluble pollutant, has high efficiency in color removal, increase the MPR performance for POMSE treatment, and low tendency of membrane falling to occur. Methodology. Ladies and gentlemen, for the flowchart of the study, the flow of this study will be started with synthesizing of zinc or clay nanoparticles. Then, POMSE treatment will be conducted via MPR with different pH and different zinc or clay loading. The quality of the permeate will be analyzed whether it is compliant to the standard or not. Lastly, analysis of membrane falling mechanism will be conducted using MATLAB software. Okay, for the material and chemicals that will be used in the study are as shown in this video. The sample will be collected from palm oil mill located in Kluang, Johor. Okay, for the preparation of zinc or clay, the zinc or clay synthesis will be started with firstly mix the prepared oxalic acid solution and zinc acetate solution together. After 5 minutes stir, kaolin powder will be added and continue stir for 12 hours. The reaction will produce precipitation product that will be filtered and rinsed with the ionized water for several times. Next, precipitate will be dried in oven for 1 hour to reduce water content and calcined in furnace to remove any impurities. Next, for permeate analysis, POMSE sample and zinc or clay nanoparticles will be stirred in MPR to obtain the adsorption-desorption equilibrium of photocatalyst, and permeate will be pumped out. The collected permeate will then be analyzed using analytical method to check its pH, color, BOD, COD, and turbidity. For the mechanism of membrane falling, it will be elucidated using MATLAB software. Expected result. Okay, now for the expected result. The expected result of the experiment have been clarified as follow the objective of this study. The expected optimum pH for POMSE treatment is under pH 7 as it is most approximate to the neutral condition of wastewater. Next, the zinc loading for 0.3 gram per liter is expected to give the best result in treatment of POMSE as the least amount of loading will result in lower cost for implementation industry. Besides, the water quality of permeate is expected to meet the Standard of Environmental Quality Act 1974. And lastly, the flux deadline and mechanism of membrane falling are expected to be successfully clarified through model fitting according to the theory of blocking filtration laws by using MATLAB software. Conclusion. So, for the conclusion, this study is expected to follow the main objective, which to investigate the effect of pH and zinc or clay loading on the performance of POMSE treatment via MPR. As I have explained, the clay would help to support the ZnO and enhance the photocatalytic degradation activity. Thus, it can be concluded that zinc or clay enables to increase the performance of the photocatalytic degradation activity on POMSE treatment via MPR. The investigation of zinc or clay as photocatalyst in wastewater treatment is at its early stage. Thus, further exploration and investigation in these areas are essential to gain more knowledge and understanding. Okay, for your information, here is the Gantt chart of the proposed project. Yellow indicates the planned progress of this project, while red indicates the actual progress of this project. Okay, that's all from me. Thank you. Have a good day.